My name is Jeff with two F's like the two feathers on a Boyd, and my last name is Boyd. I and my family were flying from Europe to the United States. We had just gotten over Greenland, and you could look out the window and see white everywhere. It is a huge glacier, and this voice comes on the loudspeaker and says, "Is there a doctor on the airplane?" And I said to myself, "Oh crap." And my wife sitting beside me said, "Jeff, should you respond to that?" And I said, "Jeepers, the last thing I want to do as a psychiatrist is to manage someone's cardiac emergency on an airplane at 37,000 feet. Maybe if I just sit here, some real doctor will answer." But then the voice comes back again. "Is there a doctor on the airplane?" And my wife, who generally has much more confidence in me than I do in myself, said, "Come on, Jeff, you can handle this." And so I got up and I said, "Well, look, I'm a doctor, but I'm a psychiatrist." And they didn't care that I was a psychiatrist. They took me to the problem. There was this woman, a middle-aged, older woman from Iran, sitting there, spoke no English, only Farsi. And only the co-pilot spoke Farsi. He had already come from the cabin and spoken with her and translated. And sitting beside her, there was this wonderful nurse, Carol, who seemed to really know what's going on and know her stuff. Carol had a stethoscope and blood pressure cuff, and she explained the picture, which is that the woman was rather vague about what was wrong. She didn't feel good. That's all she really said. She had no chest pain. She had no difficulty breathing. She didn't look like she was in great distress, except that she sort of looked uncomfortable. She spoke no English, as I say, and she was not in any pain anywhere in her body and could not explain in any detail what it meant that she didn't feel good. And Carol had taken her blood pressure and pulse and found that when there was a lot of frenetic activity among the stewardesses, it seemed to go up a little bit. It was not very high, and that the same both with her blood pressure and her pulse. I pieced together the picture as best I could. There was a lot of frenetic activity. People were anxious. The stewardesses were coming to check with me. The pilot sent me a message. "It would be really expensive and inconvenient to land here." Ha! I'm supposed to make that decision. So anyway, I'm putting together the picture, and as nearly as I can tell from the translation, the woman has no cardiac or pulmonary illnesses, and in fact she was not very well educated, and she had no idea what illnesses she had, and she took some pills, but she had no idea what pills they were, and she didn't have them with her, and there was a white pill that she was supposed to take this morning but had forgotten to take. And I began to piece together that most likely this was anxiety. I reasoned that the more people around her were anxious, the more she was going to be anxious, and it was the anxiety that was driving up her blood pressure and pulse. Carol agreed with my assessment, and so I passed a couple of rules. The biggest rule was that the stewardesses were to mind their own business. They were not to come within 10 feet of this woman, except for their usual work of delivering food and taking drinks and stuff like that. My rule was that Carol was the only one who should talk to her. I will not come back in this area. I'll sit 10 seats forward. Carol will come up and report to me every 20 minutes, having just taken her blood pressure and pulse, but no more frequently than that. And with that regimen, things calmed down, and her pulse and blood pressure came down, and everything just mellowed out, and eventually we got beyond the white glacier out the window. Greenland is huge. It takes an hour to fly across. So eventually we started descending towards Philadelphia, and I went to talk to the stewardesses and said the one other thing was that they should phone ahead and make sure that someone escorts this woman through customs and immigration and makes things just flow effortlessly and gets her on the next flight to Detroit, where her family was. As we approached the landing, the stewardesses gave me a very expensive bottle of champagne from first class. The take-home message from this story is, flying high, we can still figure things out. that flight over Greenland is not nearly as colorful as the flight of Dr. Quantum, who claims that what they taught us in school isn't really the way it is.
So, what they taught us in school isn't really the way it is, and that our senses are playing tricks on us. You just gotta wonder, what is this reality that we find ourselves in? Quantum physics says it's all just waves of information. Do I believe that? I hope so. Yikes!
Just as we solved some medical problems in that flight over Greenland, so also in this half of the video, we're going to seek to solve Dr. Quantum's problems. Now, what problems? Well, he did not end up well running into a cement wall. Not good. Prior to that, he's having a blast, sort of like with some manic energy. You know, this whole idea that reality is an illusion and that quantum mechanics says everything is just waves of information. I'm a medical person, I'm a psychiatrist, and now medical people really kind of believe in the existence of reality. We believe that in general you're better off being realistic. I mean, I debate this all the time with schizophrenics and people who are psychotic. Does reality exist and should it be taken seriously? Usually it's better off if you take it seriously and not treat it as an illusion. I claim that Dr. Quantum's problems of living in the stratosphere and not knowing where the ground is a symbolic representation of the fact that quantum mathematics is living in the stratosphere and does not immediately appear to be related to the physical world that we live in. Every science is based on probabilities. For example, what's the probability of my airplane landing? What's the probability of your sports team winning the pennant?
And the Giants win the pennant.
The one and only exception is quantum mechanics, which does not use probabilities but amplitudes, which are the square root of probabilities. This makes quantum math very abstract, and if you open any textbook of quantum math or listen to any lecture, you're immediately off into the stratosphere with Dr. Quantum, and nothing really connects to reality. Every once in a while, a so-called observable drops out of the mechanism. Otherwise, there's no apparent connection between quantum math and the physical world we live in, and I'm going to try to build that connection, something that no one else has ever done. The totally unique thing about quantum math, the essence of all quantum math, is these amplitudes. Now, these amplitudes are everywhere. They're big, they're conspicuous. What do they correspond to in the physical world? I mean, they must correspond to something. The answer is that the amplitudes correspond to elementary rays. Elementary rays are the physical analog of amplitudes. Amplitudes are not just an abstraction in science. They are based on something in the physical world, and that something is elementary rays. In his book QED, Richard Feynman talks about amplitudes as being tiny arrows that spin and move out from the light source, defining the probability amplitude of the photon going in that direction. Feynman believes these tiny spinning arrows are real, but he can't quite figure out where they exist in reality. Well, I claim they are elementary rays. They start at the detectors and they move towards the particle source or light source, a corkscrew defining the probability amplitude that the photon will go in that particular direction. To reiterate, Feynman talks about spinning arrows, i.e. corkscrews going out from the light source in all directions to define the probability amplitude that the photon will go in that direction, and I simply reverse the direction of those waves and say that they come towards the photon source and define the probability amplitude of the photon going in that direction. I also change the name from probability amplitude to elementary ray. Now, you may believe that all waves carry energy, but the wave equations of quantum mechanics do not convey energy. They convey probability amplitudes or probability densities. And that same thing is true of elementary rays. They're not carrying energy, they are carrying probability densities. In TEW, it is the particles that carry the momentum and energy, and they follow elementary rays because those are the probability amplitudes. That's just the way the world is rigged up. This is a standing wave on a river, and these are 6 standing elementary rays found inside a hydrogen atom. Based on these assumptions, it is easy to show that elementary rays live in a Hilbert space. Hopefully, we have brought quantum math down to earth where it can be understood on a human level, as opposed to Dr. Quantum's approach, in which the only way to bring quantum math out of the abstract stratosphere is to run it headlong into a cement wall. Putting this all together, we've laid the foundation for quantum mechanics, and finally the whole system has calmed down. We've landed in Philadelphia, and my wife and I are going to go enjoy this bottle of champagne. The take-home message from this video is, flying high, we can still figure things out.